Hello guys, so today we are going to discuss about study unit 12 and this chapter is known as analysis, forecasting and strategy. In this chapter we have following topics. 12.1 we have correlation and regression. 12.2 we have learning curve analysis. 12.3 we have expected value and sensitivity analysis, and 12.4 and 5 we have strategic management and planning. So we are going to start with correlation and regression analysis. Please remember guys, unit number 12 which we are going to start today, 13 and 14 which is about budgeting, 12 is about forecasting and strategy, but 13 and 14 is about budgeting. So these three chapters are called planning, budgeting and forecasting domain, and it is your 20% of your exam. This chapter, especially unit 12, is also very important from essay point of view, because sometimes they test the question in essay style question. So let's start now. We are going to discuss now. So 12.1 is guys correlation and regression analysis. So we are starting with this point. What is the forecasting? Actually guys, forecasting mean to say, like whenever you are trying to make any plans or any budget, so forecast are the basis for the business plan and budgets. Forecasting simple mean to say like prediction, like when you want to make prediction for the future demand, maybe you want to make the prediction for the cash collection. So this is what is called forecasting. So there are two types of forecasting methods we can use. One is called qualitative forecasting methods. Second is called quantitative methods. So what is the difference, guys? Under qualitative method, we do not apply any mathematical equations, any formula, okay, or any graph. Without any mathematical model, mathematical equations or graph, if you will make prediction, that is called what? Qualitative method. Now, what are the examples? For example, here, forecasting rely on the manager's experience and intuitions. Here we are not going to use any mathematical models. For example, if you are a sales manager and I'm asking you what could be the forecasted sale for next year, so based on your experience, you can give me some figures. So that is called qualitative, because you are not going to apply any mathematical models. So then there's another techniques are there, forecasting techniques. Those are called quantitative methods. When we use mathematical models, mathematical equations, or graph or any formula to make the prediction for the future, so that is called what? Quantitative method. Now, guys, we have a first word here. What is the correlation analysis? So first we need to understand this word. Correlation is what? Correlation is the, let me just tell you here, correlation is the strength of linear relationship between two variables, okay, expressed mathematically in terms of coefficient of correlation, which is denoted with R. So let me explain what it is. For example, guys, we have a marketing cost, marketing expense versus sales. So these are two variables. Variables means that these are two factors. Understood? Obviously, if you will spend more money on marketing, maybe your sales might increase. Or if you will spend less money on marketing, maybe your sale might decrease. Understood? So it means there is a relationship between these two variables, in which marketing is one variable and sale is another variable. So marketing, which we can say is the independent variable, and sale, we can say this is the dependent variable, because sale is dependent upon marketing, not the marketing is dependent upon the sales. Okay, so when we express a relationship between two variables, and this relationship expressed mathematically. Mathematically means we can give some number. For example, we can say relationship is 0.7, our relationship between these two is 0.8, our relationship is 0.9. It could be any value. That interpretation of the value I will tell you, don't you worry. But what is correlation? Correlation is the relationship between two variables which can be expressed mathematically. And this mathematical values which we will use, like correlation is 0.1 or 0.7 or 0.8, whatever it is. So actually these values are called coefficient of correlation, and this is denoted with R. So R values, now it's time to understand R values, which is called what? Coefficient of correlation. R values, guys, will range from +1 to -1. It could be any value between +1 and -1. So this is the range, +1 and -1. It could be any value between these two, +1 and -1. So now we need to understand what it is, how it will work. Don't worry. So what does mean by +1? What does mean by -1? Or if there is any value, could be 0.7, could be -0.03. It could be any value between these two ranges. So how you will, express or how you will interpret those values, this is I'm going to explain now. So far just we discussed only like if you can develop any mathematical relationship between any two variables. So that is called what? Correlation. And correlation is also called coefficient of correlation. And it is always denoted with R. And I told you R values will fluctuate from +1 to -1, which I'm going to explain now. So here we go, guys. Okay, as I told you, coefficient of correlation is what? Relationship between two or more variables. Variable means factors. When you can develop a relationship, so one variable could be independent and other variable could be a dependent variable. As I give you example, marketing versus sales, in which marketing was independent variable, but sale is dependent. And I told you R values will fluctuate between +1 and -1. This is what I'm going to explain now. What does mean by +1? Guys, please remember, +1, here it is the interpretation now, try to understand. Plus, whenever R is equal to +1, this +1 is called perfect direct correlation. Perfect direct correlation. Okay, whenever the value is +1. Okay, let me tell you here how it is interpreted now. For example, guys, you have passed, let's assume, 5 years data of two companies. One is company X and second is company Y. And you are studying the relationship in stock price movements of these two companies. Okay, and you have a past 5 years data. And what you have observed, that whenever company X stock price increased by 50%, at the same time company Y stock price is also increased by 50%. Now you will notice here in the second example, and you also notice whenever company X stock price is decreased by 30%, at the same time company Y stock price is also decreased by 30%. Now, if you will notice here, what you have noticed here, when X price goes up, Y also goes up. Understood? And you can see here proportionate of change is also same. When X price goes down, Y also goes down. And you can notice here proportionate of change in both companies' prices is also same. So this is called +1, perfect direct correlation. What is perfect direct correlation? Like both variables, they are moving in the same directions. Both will go up or both will go down. They are moving in the same direction and they are changing with the same proportionate. For example, if one is increased by 10%, second is also increased by 10%. If one is decreased by 5%, second is also decreased by 5%. So both variables, they are moving in the same direction and their proportionate of change is also same. So this is called what? Perfect direct correlation. Now then we have here, guys, if R value is -1, -1 is known as perfect inverse correlation. What it means, for example, again, we have two companies, company X and company Y. And you have passed your data and you have observed that when X price increased by 10%, Y price is decreased by 10%. So see what happened. If X price goes up, Y price goes down. They're moving in opposite direction here. For example, you notice that when X price is decreased by 10%, Y prices are increased by 10%. So what it is, it means if X is decreasing, Y is increasing. So what does mean by -1? -1 mean to say they are both variables, they are moving in the opposite direction, but they are moving in the opposite direction with the same proportionate. This is what is called R is equal to -1. Understood? Now, guys, R value could be any value between +1 and -1. Now, let me tell you here. I'm going to explain here. For example, R value is, correlation value is 0.7. 0.7. And I'm giving you X company and Y company data. Okay, please remember here, this is a direct relation. Direct means a positive relation. Positive means if one will go up, second will also go up. If one will go down, second will go down. So my question is that R value is 0.7 and X prices has increased by 10%. This is the data is given. Now I'm asking you, what is the movement in Y prices? In Y prices, Y company prices. Obviously, it is a 0.7 plus 0.7, right? Y will also go up, but Y increase in Y will be this 0.7. 0.7 means say 70%. Increase in Y is the 70% of first change. First change was how much? 10%. So if I'll take 0.7 of 10%, so it will give you 0.7 itself. It means if X is increased by 10%, Y is increased by 0.7, mean to say, sorry, I have to take 0.7 of 10%. Okay, so it will be 7%. If X increased by 10, Y increased by 7%. Another example. For example, I'm saying that R is 0.3. 0.3, you can say correlation is the 30%. For example, now X prices has decreased by 50%. It means Y obviously will also decrease. But with how much percentage? With 30% of the first change. First change was how much? 50%. And correlation is 30%. I'll take 30% of first change. Whatever you will get, you will get maybe 15. So it means Y prices will decrease by 15%. Now, guys, you might be given this information like that also. For example, R value is 0.2, but it is minus 0.2, 20%. Minus 0.2 means say 20%. But it is minus, inverse. Now I'm telling you X prices, X variable has increased by 100%. It means Y variable will decrease, not increase, because it is a minus. But with how much percentage? With the 20% of the first variation. First variation was 100%. And if I'll take 20% of that, it will give you 20%. Okay, it means if X prices has increased by 100, Y prices will decrease by 20% because it is a inverse relation, because it is minus. Understood? So that is why R value could be any value between +1 and -1. I hope it is clear. Now, guys, please remember here. If R value is 0, like you are not able to predict any relationship between two variables, then we say there is no correlation exists. When there is no correlation, R value will be 0. Or sometime, okay, here we go, guys. This picture you also need to remember. And then I will tell you how question will be tested from this discussion. Guys, if you look at this picture, let's assume this is your y variable, this is your x variable. Okay, this picture represents perfect direct correlation. Direct means a positive correlation. For example, if you are sitting at this point, y value is here, x value is here. If you're sitting at this point, y value will be here, x value will be here. If you're sitting at this point, y value will be here, x value will be here. If graph is upward sloping this way, if it is slope like that, so this means to say perfect direct relationship. And here it is called R is equal to 1. If graph, let's say this is y variable, this is x variable, and this is downward sloping now, downward. So here it means it is called perfect inverse correlation. For example, if you're sitting at this point, it means y value is here, but x value is here. If you're sitting at this point, it means y value is here, but x value is here. In first example, y value was higher, x change was lower. In second example, y change is lower, x change is more, because this is zero region, right? This is zero region. So if it is downward sloping, it is called what? Perfect inverse correlation. Then guys, this picture, if picture is like that, it is like a strong direct correlation, but you should remember those 2 points, because otherwise thousands picture can be created. So those 2 pictures you have to remember. If it is upward sloping, it is positive, perfect direct. If it is downward sloping, it is perfect inverse correlation. Now point is that how questions will be tested in your exam. Please remember. Note, we have a note here. Examiner might ask you to show weakest correlation or strongest correlation. Please, I'm giving you a very simple answer first. If any number which is close to zero, because, you know, just to understand this concept, just remember the climate example in your mind. For example, you are living in UAE and nowadays 40 degrees temperature. Obviously, as we will move to the winter side, so it will go to 30, for example, degree, then 20 degree, 10 degree. Now let's say you are living in UK, so temperature is 40 degree. So obviously from in winter season, it will reduce from 40 to downward, 40, 30, 20, 10, it will reach to zero also. Then it will be minus, for example, 10, minus 20, assuming minus 30. Okay, guys, in between there is a zero. Any value which is close to zero, so it means it has weak correlation. And any value which is close to one, it means it has a strong correlation. I'm not saying it is inverse or direct. I'm saying in simple words, is it weak correlation or it is strong? So if value is close to zero, it is weak correlation. If value is close to one, it is strong correlation. Let me give you few couple of examples. Okay, so for example here, guys, I'm showing you 4 values. I'm saying that we have these are R values. R value is 0.9. It is minus 0.9 means a minus 90%. Then there's a one R value 0.4. There's a one R value 0.85. One value is a 0.03. Now, if I will ask you, I'm not saying is it direct or inverse. I'm simply asking where we have a weak correlation. Weak. So which value is close to zero? This value is close to zero. Why? Because it is 3%. 0.03 means 3%, minus 3%. And if I'll ask you where we have a strong correlation, so which value is close to 1? It could be +1 or it could be -1. Which is close to 1? Close to 1 is this value 0.9 because it is 90%. Even it is minus. So this is your strong correlation. Even it is inverse correlation. And this is your weak correlation. Even it is inverse correlation. Now I'm giving you one example here, and you will tell me where we have a strong correlation, where we have weak correlation. So here we have value 0.6, 0, 0.06, 0.6, 0.7, 0.9. Tell me, guys, where we have weak correlation. Weak means close to zero. This value is close to zero because it is only 6%. And this is close to 90%, close to 1. It is a strong correlation, even it is minus value. Understood, guys? When value is close to 0, it represents weak correlation. When value is close to 1, it represents strong correlation. Okay, so now I'm changing my question and you will tell me one more time. For example, we have a minus 0.8, minus 0.6, 0.9, 0.9 and 9. I'm asking now where we have a strong, now this is another question, strong inverse correlation. Strong inverse correlation. Inverse means your answer is in these two values now, in negative values, because I'm asking about inverse. Strong means which is close to -1. This value is close to -1. So here we have a strong correlation. And this is the weak correlation because it is less stronger than the first one, right? So we can say it is a weak correlation as compared to the first one. Now I'm asking a question where we have a strong direct correlation. Strong direct correlation. Now, direct means a positive values is your answers. So this is strong because it is 99%. And this is weak as compared to that because it is 90%. So this is more close to 1. Understood, guys? So this is how question will be tested. I hope so you got it because it's just initial discussion. So now we have here another point. We are talking about now coefficient of determination. There's another definition, theoretical they will test. Actually, these all are statistical words, but you have to be aware with these words. Guys, coefficient of determination, this is another definition. It is also called R square. You know what was R? R was correlation, right? Right or wrong? That is called coefficient of correlation, right? So if you will take R square, square of the R. So this is called now coefficient of determination. It is also called coefficient of determination or coefficient of correlation squared. Okay. So now the point is that what is the interpretation of this? So let me give you example. For example, guys, I'm going to give you example here. For example, guys, you are running a car wash business. So car wash business is one variable and weather is another variable, climate. Okay. Obviously, guys, weather is the independent variable, but car wash business is the dependent variable. How? Obviously, if there will be more rains, if weather will be rainy, so car wash business will maybe increase, right or wrong? If weather is always sunny, maybe car wash business will decrease. It means car wash business is a variable which is dependent upon the weather. Not the weather is dependent upon car wash. I cannot say, for example, if I will wash 5 cars, so there will be a rain. No. But if there is a rain, so we can make some relationship. Yes, there might be increase in car wash business. Okay. So I'm saying that there is a correlation. Correlation R, just R value is point, for example, 8. There is a correlation of car wash business and weather, how much? 0.8. So now if you will take R square, which is also called coefficient of correlation squared or coefficient of determination. So what I'll do, I'll take square of 0.8. If I take square of 0.8, it will give you 64%. Right or wrong? Or 0.64. Understood? Or 64%. Now we need to understand what does mean by this 64%. It means this R square 64% represents what it represents. It represents that your car wash business will affect 64% of times, you can say this way. Your car wash business, which is dependent variable, will affect 64% of times due to change in weather. You know how much total percentages are there? Total is 100. Out of 100%, if your car wash business will change 64% due to the change in weather, it means remaining 36%, it will change due to other factors. For example, let me say one more time. For example, if I'm just now changing, for example, I'm saying that 0.9 is the correlation. If I'll take square of this, so it will become 81%. It means your car, if there's 81% coefficient of determination, it means your car wash business will change 81%, okay, due to change in weather. So total percentage is 100%. If 81% is it's changing due to change in weather, it means 19% it will change due to change in other factors. This is what is called coefficient of determination. So we can say this way also, guys, a definition is written. But I told you simple words. So here they're telling you mathematically, the coefficient of determination, which is R square, is the proportion of the total variation. It's a proportion of the total change in the dependent variable. What was dependent variable in my example? Car wash business. Like how much car wash business will change due to change in independent variable. Understood? So in my language was more simple, guys. Okay, this is written technically. So now we are going to talk about regression analysis. Regression analysis. Regression analysis is also called least squares analysis. Understood? So you have to remember, guys, what is the difference between regression analysis and correlation? Actually, correlation quantifies the strength of linear relationship. Like for example, is there the relationship of 0.7, 0.8, or minus 0.6. So correlation quantifies the strength of linear relationship between a pair of variables. Understood? Whereas regression express the relationship in form of an equations. So we are going to study actually equation. So regression, it's also called what? Least square analysis. And this regression equation we use in forecasting, which is our topic. So there are two types of regression is there. There are two types of regression. One is called simple regression analysis. And second is called multi-regression analysis. That I'll tell you later. So what is simple regression analysis? So it is a relationship. In simple relationship, we will always have only two variables. Okay, only two variables. Two variables means say factors. And obviously one variable will be independent variable and second variable will be dependent variable. Like as I gave you example, marketing versus sales, in which marketing expense was independent variable and sales was dependent variable. Right? So if you have only two variables, so that is called simple regression. And there we have one equation for simple regression, and that equation is called y is equal to a plus bx. And now this equation has two different uses. Understood? These equations obviously we will use for the forecasting. So that is why forecasting can be done through equations also, and forecasting can be done through the graph also. So that is why we have a two use of this ratio. Right? So first we can use this ratio in calculation. It is the first use. And second use of this ratio is in the graph. So I'm starting with the first calculation side. So if you're using this equation, which is y is equal to a plus bx, so in calculation, y is always equal to total cost. Okay, which we have to calculate mostly in the exam question. Then what is A? A stands for fixed cost. Because obviously, guys, total cost is always the combination of fixed cost plus variable cost. If y is your total cost, which we will calculate, so A is always your fixed cost. And fixed cost is also called constant coefficient. Please remember this word. Constant is the word for fixed, right? B is your variable cost. It is also called variable coefficient. Obviously, we have to calculate A also, B also, and Y also. And then what is X? X is the activity level which will be given. Understood? So we have to calculate actually total cost for any X activity level. So this equation now, which is Y is equal to A plus BX, as I told you, we can use to forecast the future results. And to complete this equation or to apply this equation, sometimes these equations will be mingled with high-low method. Okay, like in calculations, they can mix high-low method with this equation, and then they will ask you to produce certain calculations. I have to actually explain what is the high-low method. Actually, high-low method is used to split total past cost, total past cost into what? Variable cost and fixed cost. Like high-low method is a one technique which we can use to split the total cost into variable portion and into fixed portion. Understood? For example, if your monthly expenditures are $100 and you have this data over 5 years, so you can split like in $100, what is the portion of fixed cost and what is the portion of variable cost by using high-low method. And first, because you remember the equation y is equal to a plus bx. Y is equal to a plus bx. What was a fixed cost? What was b variable cost? What is y total cost? What is x activity level for which you want to calculate total cost? So that is why to calculate a, which is your fixed cost, and b, which is your variable cost, we will apply which method? High-low method on the past data. Obviously, once we will drive the fixed cost and variable cost from the past data, the same fixed cost and variable cost we can use to make the prediction for the future. Understood? So how it is going to work? So I'll tell you now, please, with the help of example, how regression equation can be applied along with high-low method. So guys, we have example on your screen. A company has the following cost data. We have here months. We have months of April, May, June, July, August, and September. And here we have a machine hours. Machine hours operated are work 1,000, 1,600, 1,200, 800, 1,200, and 1,000. And here we have maintenance cost. Maintenance cost, you can say total cost. It could be any cost, maintenance, production, anything. So this is the cost for each month is given here for these number of hours. Now, what is the question? We have to calculate total cost for the month of October. For the month of October, if we plan to work how many hours? 1,300 hours. Now you can check this question. In this question, guys, this is your machine hours column, right? We don't have any 1,300 hours. And this data is available up to September, but we have to calculate the total cost for the month of October if we plan to work how many hours? 1,300 hours. So then how you will do it? How you will make the prediction? Actually, here you are making now forecasting. So step number one, guys, what we will do, we will apply high-low method. Okay. And we will calculate, step number one will be what? We will calculate here variable cost per hour we will calculate. Why? Because the data is given in hours. If data is given in units, we will calculate variable cost per unit. Understood? If data is given in kgs, we can use variable cost per kg. So this is the first step. We are going to calculate variable cost per hour. And then we will calculate then we will calculate fixed cost. So variable cost per hour, how you will calculate, guys? This is the formula you have to memorize. So these are called activity levels now. It could be machine hours, units produced, quantity used. It could be anything. Okay, so we will pick two activity level. One is the highest, second is the lowest. That is why this method is called high-low method. Highest activity level, where we have here. So we'll pick it here and we will write here 1,600 hours. And then we'll put the lowest activity level Please don't make mistake here. Lowest activity level is how much? 800 hours. We'll deduct. It means what is the formula? Highest activity level minus lowest activity level. Understood? And in the numerator, we will write their cost. Cost at highest activity level is how much? $3,400. Then cost at lowest activity level is how much? $1,900. It means this is the cost at high activity level. This is the cost at low activity level. So this is actually the formula. So we'll pick first highest activity level and then lowest activity level. This will be your denominator. And then in the numerator, we will write their cost. Understood, guys? And now we will solve it. So how we will solve? Obviously, first I'll take the difference of numerator. So 3,400 minus 1,900. It is going to be $1,500. And then I'll take that, I'll solve denominator. So 1,600 minus 800. It will give you how many? 800 hours. It means the difference in cost is $1,500 and difference in hours at two different activity level is 800 hours. So we'll solve it. So you will get variable cost per hour. Okay, so variable cost per hour will be $1.875 per hour. $1.875 per hour. This is your variable cost. This is the step number 1. Then what is the step number 2, guys? This is step 1 is the part of high-low method. Step 2, in which we will calculate fixed cost in total. We have to calculate. That is the second step of high-low method. First step was to estimate variable cost, and second step is to estimate the fixed cost. And please remember, when you calculate the fixed cost, we will always calculate the fixed cost at selected activity level. Only these values I'll use. Okay, so please focus with me. So now step 2, we are calculating. We are going to calculate fixed cost at any selected activity level you can calculate. Those activity levels which you have used in the step number 1. Okay, so what equation we will write? I'll write the equation like this now, because I want to calculate now fixed cost, which will be equal to total cost minus variable cost. So let's try first. I'm going to calculate fixed cost at 1,600 hours. You know, this was the selected activity level, right? In the step number 1. So at this point, we have a total cost, $3,400. You can check from the question. It is the same value. This was the total cost. Minus now I want variable cost. I have already variable cost per hour, which is 1.875 per hour. But for how many hours I want? I want variable cost for 1,600 hours. I'll multiply. It's 1,600 hours. If I'll take 1,600 hours, multiply by 1.875, this will give you variable cost. And if I'll deduct from the total cost, this will give you fixed cost, and maybe it is going to be $400. You can cross check. Same way I can calculate at 800 hours also, which was also selected activity level. So their total cost was how much? $1,900. You can check from the question. At 800, it was $1,900. Understood? You can try again. At 800, our total cost was $1,900 minus I need to deduct variable cost. Variable cost per hour is 1.875, which I have calculated in step number 1. But now I want variable cost for 800 hours. I'll multiply with 800. This will give you variable cost. I'll deduct from the total cost. So this will give you what? Fixed cost as $400. But please make sure you should use the same. You should use the same activity level which you have used in step number 1. So now, guys, we can apply a regression equation. What was the regression equation? Which is step number 3. Because what was the requirement, if you remember? So we are planning to work 1,300 hours in the month of October. For that, we want to calculate the total cost. So now I'll apply that equation. What was the equation? Y is equal to A plus BX. Y, as I told you, it is total cost. A is the fixed cost. Fixed cost is how much? 400. Plus B. B is the variable cost, which was 1.875 per hour. And X. X is what? Multiply by, obviously, you have to multiply with the X also, right? X is the activity level. For how many hours I am planning to predict now? For 1,300 hours. So this will give you variable cost. Like B value is the variable cost. X is the 1,300 hours. So this will give you variable cost portion plus fixed cost. If I will add, so fixed cost plus variable cost, this will give me total cost of 2,838. So this is the total cost. So it means high-low method. Our regression equation can also be applied with the high-low method. I hope so it is clear. This was the simple regression. In simple regression, guys, we always have two variables, right or wrong? One is dependent, second is independent variable. Now, please also focus. I told you this y is equal to a plus bx equation can be used in calculation also, which I just told you. In calculation, y means a total cost, a means a fixed cost, b means a variable cost, x means to say activity level for which you are planning to predict the cost. And this regression equation can also be used in graphical language. Because graph is another way to make the prediction. But you are not required to prepare any graph in your exam. But at least you should remember the graph. Like what does mean by in graph, what is the y, what is a, what is b, what is x. So let me show you an example, guys, for the graph. In small example, you are not required to draft any graph in your exam. For example, we have advertisement data here in thousands and we have a sales in millions. For example, if you will spend 71,000 on advertisement, so you will get sales 26.3 million. Okay, if you will spend 35,000 on advertisement, you will get sale of 15.1 million. So this other data is also available. So how we can prepare graph is very easy. On y axis, so we can write what sales. Sale is your which variable? Sale is your dependent variable. And on x axis, we can write what? Advertisement. Advertisement is what? Your independent variable. And now we'll pick the values from here and we will try to place the dot. For example, if advertisement expense is 71,000, for example, we have to write first advertisement 10,000, 20,000, 30, 40, 50, 60, 70, 80. So 71,000 will be somewhere here. So sale is how much? At 71,000, sale is how much? Sale is 26.3. So sale is 26.3. For example, sale is 5, 10, 15, 20, 25, and 30 million. So here is 26, something like that. Understood are here somewhere. So now in front of this point and then on the top of this point, I'll place a dot. Same way for second data, I will place a dot. Like if your marketing is 31, so sale is 13.9. So you will get another dot. Most probably this dot will be there. Okay. You can just, I know how to, how to prepare a graph. That is not the part. Then once all these dotted are plotted on the graph, then what we will do, we will take a scale, and with the scale, don't do zigzag. With the scale, we will try to connect with a straight line. This is also called the line of best fit. We will try to connect this dot with a straight line. Some dots will be connected, some will not be connected. Okay, and once you will draw this line will be like that, as it is showing on the screen. Understood? Now we have to read from the graph what is A, what is Y, what is X, and what is B, etc. Please, guys, in graphical language, Y, because equation was what? Y is equal to A plus BX. In graphical language, Y is always equal to your dependent variable. But it is dependent. And X is always your independent variable. Independent, like advertisement. Y is what? Your sale in this example, which is dependent. X is independent variable, which is advertisement. Then what is the A and B? Okay, A and B. This slope of the line is called B. the B is also called the y-intercept. Huh? Okay, let me just show you from here. Here it is written. Sorry, so the B is what? B is the slope of the regression line which was drawing like that. The line of best fit. Then what is A? A, I'm telling you, A is called the y-intercept. Because this line, if you look at this line is intercepting Y at this point. This point is called A, the y-intercept. Okay, guys. So what is Y? Y is dependent variable in graphical language. What is X is the independent variable, which is advertisement. What is B? The slope of regression line is the B. And what is the A? A is the y-intercept where this slope, this regression line will intercept the Y. That point is called A. You have to remember this, just this simply they will ask you in graphical language, what is A, what is B, what is X, and what is Y. Okay, guys, I hope so it is clear. Now we are going to discuss multiple regression. I told you there are two types of regression. One is called simple regression. Second is called multiple regression. In simple regression, we have equation y is equal to a plus bx. And this equation has two uses in graph and in calculations. But in multiple regression, guys, and in simple regression, there was one more point. We have only two variables. One variable was dependent and second was independent. But in multiple regression, guys, in multiple regression, so you have one dependent variable, but many means say more than one independent variable. Let me give you example. For example, if you will practically look at the sales. Sale is dependent variable, yes, true. But sale is not only dependent upon the marketing, no. It is dependent upon the quality of the product also. It is dependent upon the price of the product also. It depends upon the services after sale also. It depends upon the availability of the product also. It depends upon the packing of the product also. So there are so many different factors which will contribute towards the sale, right? So that is why when you have one dependent variable and more than one independent variable, that is called multiple regression. Just you need to know only the formula. There is no implications in CMA exam. Okay, guys. So what is the formula for simple equation? For simple regression, what was the equation? Equation was y is equal to a plus bx. Right or wrong? Now, if you have multiple independent variable, so this equation will be like that: y is equal to a plus b1 x1, then plus b2 x2 plus b3 x3. So this will continue. Okay, this is the formula for multiple regression which is written here. Okay, there is no guys questions for this. They will just ask you, okay, like in multiple regression, how many independent variables are there or how many dependent variables are there or how formula looks like. So I just told you here. Understood, guys? I hope so it is clear. Okay, guys, so then we have here, now we are going to talk about some theoretical aspects of this topic. There are some assumptions, okay, regarding this topic. These three assumptions you need to understand, guys, very properly, because there are so many theoretical questions are there in your software and you might also face in your exam. So first assumption of the linear regression model. Number one, this concept we can apply only across the relevant range concept. So you have to understand what is the relevant range concept now. We discussed even in the costing. Guys, relevant range means it is the time period in the short term in which variable cost per unit or per hour or per kilogram and fixed cost in total will remain constant. That is called what? That is called relevant range period. Relevant range is what? It is the time period in which these two things will happen. Your variable cost per unit will remain constant and fixed cost in total will remain constant. So that is called relevant range. And please remember also, guys, what it means here. What is the assumption here? Assumption is that this regression equation or regression model we can apply only in the short run. Only in the short run, not in the long run. It is valid across the relevant range only, not beyond the relevant range. Understood? Because if you, what is the proof for that? Do you remember we are using y is equal to a plus bx? What was the a fixed cost? B is the variable cost. Do you remember this fixed cost and variable cost we calculated from the past data? Agreed or not? We calculated from the past data and we assume this fixed cost and variable cost will not change. And we use same fixed cost and variable cost to make the prediction for the month of October. In my example, if you remember. Okay. So this is second assumption also. First assumption is what? Your variable cost, sorry, it can be applied only within the relevant range period, short-term period. The period in which total fixed cost and variable cost is not changing. What is the second point? And obviously I gave you example like for the past relationship. This is the first point. Second one is what? Regression analysis is particularly valuable for budgeting and cost accounting purpose. It is very true. If you remember in my previous example, what we were calculating? We were calculating total cost for the month of October. It means what we are calculating? Costing. We are doing costing. You can use the word for costing also. Total cost is the cost, but it is based on prediction. So obviously regression analysis can be used to prepare budgets and it can also be used for cost accounting purpose. The third assumptions of this topic is regression does not determine causality. Causality means say non-recurring items. Let me give you example. For example, sales versus marketing expense, in which sales was dependent variable and marketing is independent variable. And under regression, we assumes what we assume. We always assume dependent variable will remain dependent and independent variable will remain independent. They will never change their places. Like it will never happen that independent variable will become dependent and dependent variable will become independent. This will not happen. So this is called causality. So that is why regression does not determine causality. Understood? We always assume dependent variables will remain dependent and independent variables will remain independent. They will never change their places. Understood, guys? So let's do 1-2 question. Let me show you guys here. So here we have one question, guys. For example, in order to analyze the sales as a function of advertisement expense, again, this question is about sale and advertisement expense. The sales manager developed a simple regression model. The model included the following equation, which was based on 32 monthly observations of sales and advertising expenses with related coefficient of determination is 0.9. Do you remember coefficient of determination means R square? 0.9 means 90%. It means your sale is changing 90% of times due to change in marketing expenses. Understood? But this is not the question. Let's read the question. I'm just reading the terms and explaining. They are telling you sale, this is the equation. Sales is equal to 10,000 plus 2.5 multiplied by advertisement expense. Actually here, sale is your Y. 10,000 is your A. 2.5 is your B. And advertisement expense is your X. So just complete the equation. They're telling you if the advertising expenses in the month amounted to $10,000, sorry, $1,000, the related point estimates the sales would be. They're saying if your advertisement expenses are 1,000, what will be the sales? So just complete the equation. You already have Y is equal to A plus BX. So just put it here as advertisement expense, put it here as 1,000. So now you will solve this equation. Okay, so you can calculate the sales sales is equal to 10,000 plus multiply this 2,500. And now add these two. So sales will be 12,500. Right? So this is the option D. So there are a couple of questions, guys. So I'm just showing you one more question. Remaining you will practice at home. They're telling you in the standard regression equation. What was the equation? Y is equal to B, X, A plus BX. The letter B is the best described. You know, B in graph, it is slope of regression line. It is slope of regression line. But in calculation, B is your variable cost. Variable cost is also called variable coefficient. Variable cost is also called variable coefficient. It means letter B represents what? Variable coefficient. Understood? I hope it is clear, guys. Guys, please confirm through the chat option. Is that clear?